Hello, and welcome to 5 Minute Math. Today we are looking at the third grade mathematics STAAR test 2024. My name is Aaron Davram, and we are looking at the readiness standards for third grade that fell below 60% mastery. So let's start with our lowest scoring readiness standard. This was item number 21, and it was tested just one time. And you'll see here that it is not multiple choice. It is what we call an equation editor. So students had to type in the answer, kind of like they would have to bubble in the answer before the STAAR redesign. So what do we have to do here? Well, we've got a rectangle, and students need to know that each square is 1 centimeter. So now we have our units. There are 32 rows, right? So we can just draw something like this, and we can say 32. And then we've got 8 squares. So we don't have a visual, but we can draw a visual. And so using area, which is a huge concept, 3.6c in third grade, then they're supposed to just multiply 32 times 8. There's a few different ways we learn about that in third grade, but just the standard algorithm gives us 256. So as long as they can type in 256 in the calculator, they're going to get that correct. But as you can see, only 31% of students across the state of Texas were able to get that correct. And so, what do we need to learn from that? Well, it was difficult because they didn't have a visual. So they had to apply their knowledge of area of rectangles, and they had to supply the visual. And that seems like a very simple step, but without that visual there, some students that might be second language learners, they might have difficulty reading, are going to struggle trying to make sense of the problem. They had to correctly interpret the area to mean multiplication. They had to connect these two. So the fact that it didn't have multiple choice always increases rigor because if you have multiple choice, there's always a chance you can just guess and get it correct. Or if you work something out and you get all four, none of the four answer choices are there, then you know that you need to go back and do it again. There's nothing to kind of double check your work when it's just a free entry like that. So these two bullet points down in white are going to then show us what we as educators can do to help our students with this type of problem. First, we need to help them draw a representation to visualize the problem. It might seem super simple, but that should be the first thing they do on any problem. Draw a representation, whether it be a strip diagram, number bond, number line, just rectangles, squares, whatever it happens to be. And then they need to use this graphing feature here of Cambium to create a grid with 32 rows. That is one option on Cambium is you can use the graphing feature and you can change the grid size. Now, it's a little bit small. It can be a little bit tedious, but for some students, it might be just the trick they need to really see, oh my goodness, there's 32 rows of 8 each. I need to multiply, or I need to, add 32 8 different times. But they can use this graphing feature in Cambium to help them actually visualize and draw an area model. So next we have 3.4a, reporting category 2. We had 45%. This was tested twice. We're solving with fluency 1-step and 2-step. Now look at the difference between this particular standard and these two items. Let's start with number 1. School had 375 hot dogs. After the carnival ended, 83 were not sold. How many hot dogs were sold? Right? So we could just draw a strip diagram. 375 is my total, and I've got two parts. My not sold is 83. My sold is unknown. So then that sets us up to subtract. We have to regroup once, right? 292. So very simple. It's a one-step problem. Now, I'm going to change pen colors here because I want to show you the difference between a two-step problem and a one-step problem. Look at number 22. Only 21% correct, less than half. At a weekend bake sale, we had 295 cookies sold on Saturday. Then on Sunday, 88 more cookies were sold than on Saturday. And we need the total for Saturday and Sunday. Okay, so if Saturday was 295, and then on Sunday, we had 88 more than Saturday. Well, Saturday's 295, so I had at 295 plus 88. Then I need the total for Saturday and Sunday. So what I need is I need 295 for Saturday, and then I need for Sunday the 295 and 88. I need to add up all three. But if you just look at the problems, there's only two digits there. There's only two numbers, 295 and 88, but they have to add 295 twice. So that's 18. It's going to be 10, 17, 27. 678 is our correct answer. But look at the difference between a two-step problem, 21%, and a one-step problem, which is 69%. Huge difference, same standard. So we easily answered the one-step problem. For number 22, the two-step problem, 57% chose B. So let's go back and look. 57% chose this. This is the answer to that first step. How much is on Sunday? 295 and 88 they were able to get. So they understood that, which means the issue is not necessarily addition. They need to draw a strip diagram with labels to help keep track of the units. I just did equations, but a strip diagram definitely would have helped, right? And then if they were to write a statement with the solution, blank cookies were sold on Saturday and Sunday, which matches what we have here on our question, Saturday and Sunday. If they came up with our incorrect answer of B, 383, they would have thought, 383. I didn't solve for Saturday and Sunday. 383 is only Sunday. So I think the issue with this last one here is they weren't answering the correct question. They were solving for how many's on Sunday. So sometimes the easiest way to find the answer is just to write out a statement or have them on their scratch paper write out a statement, because then they can keep track of is their statement answering the question. And because if they think 383 were sold on Sunday, all you got to do is go back and read this question and realize, oh, it's asking for Saturday and Sunday. So 3.5b is our next readiness standard. It is reporting category 2. We only had 45.5% answer it correctly. We had to see again, one step and two step, but this time we have multiplication and division problems. And we had one that was kind of simple, one that was kind of difficult. And they're actually both two-step problems here. So Eva's flower shop had 72 flowers. So she's going to place an equal number of flowers into 8 vases. So I'm going to start a strip diagram on this because I would always suggest drawing a strip diagram. So 72 is my total. I've got 8 vases. All right, so I'm just going to draw half, cut each half in half, that's fourths. Cut each fourth in half, that's eighths. So she's going to place an equal number of flowers into 8 vases. So I can stop right here, and I can put a number into each of these boxes. This is 72 divided by 8. So that's a basic fact, that's 9. Okay, so I can say that each of these is 9. 9 flowers in each vase. Now, she sells 3 vases, which equation can be used to find how many vases she sells. Well, how many does she sell? Let's put a box around it. She sells, it's not 999, right? It's 9 plus 9 plus 9. She sells 27. So that only shows up once, but if we draw a picture, we can simply solve the problem and then find the equation that matches that. Because what did we do? We divided 72 by 8 to get to 9, and then we multiplied that by 3 because there's 3 sets of 9 that she sold, and that is our answer there of 27. You see, we only had 37% correct. This one was a little bit more difficult, a little bit easier, but the problem itself was more difficult because it was a drag and drop. So we've got 4 basketball courts. There were 2 bags of basketball courts, 2 bags of basketballs for each court. So I'm just going to draw court, 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 2 bags for each. So we don't need a strip diagram. We could just do a representation. Each bag contains 7. So I don't need to draw 7 of anything or 7 dots. I can literally just put the digit 7 in there. So then, which equation can represent the total number of basketballs? Well, I've got 7, 14, 28, I got 42, and then I've got 56, because I've got 8. Really, I've got 8 sets of 7. Okay, so what did I do with my 4 and my 2? Well, I multiplied 4 by 2 to get 8 bags. and then I multiplied that 8 times 7 because there's 7 basketballs in each bag. That's the only way to get me up to my 56. Now, this was a little bit easier, 54%, because for the most part, and we'll talk about it here on this next page, the issue is they were both steps involved one operation. So number 15, it was multiply, multiply. You notice when we go back to the first one, we had to divide and then we had to multiply. So those problem situations are a little bit trickier. So they both use two-step problems, but they had a more difficult time when first step is one operation, the second step is a second operation. So I would always suggest drawing strip diagrams or pictures to represent the problem situations just like you saw me do. That helps them contextualize, am I multiplying, am I dividing? If it's addition, subtraction, am I adding or am I subtracting? Like what's happening? A strip diagram or a picture will help them identify the correct operation if they have enough practice. Now, what they need practice with are two-step problems that involve two different operations. They need practice drawing a picture and equations. So equations plus representations, whether that be a picture, whether that be a strip diagram, that is when is going to help our students build robust knowledge so that they can answer this correctly. So next, we're looking at 3.4K, forward in category 2. We've got one and two step problems here again, but now we're needing to solve. So look at what we did here. We are solving one and two step problems. Look at the previous one. It looks very similar. We're representing. So obviously those are closely related standards, but they do slightly different things. Now, how are we going to solve? Well, we're going to use pictorial models, including arrays, area models, equal groups. So really, if we're working with multi-step problems, as long as they're always drawing a representation and then always solving, you can hit both standards at once. Now, this happens to be a one-step problem. We've got Steve, he's got 75 shirts. He puts 15 shirts on a shelf. So I can present it like this. So here's my total, right? We always need to identify what's the total or what's the whole. I've got 75. He puts 15 on each shelf. So there's a few different ways to represent that, right? Where the number of groups is unknown. I'm going to represent it like this. I know that my divisor is 15. I just don't know how many 15s go up to 75, right? Now, when you think about this, this is division. This is 75 divided by 15. Well, that's two-digit division, right? First off, we don't get into long division until fourth grade. We don't get into a two-digit divisor until fifth grade. So how are students supposed to be able to do this? Well, you don't need to divide to do this because we just need to skip count by 15s, right? And so if we want, we can like create a table here and we can say these are the number of shelves and these are the t-shirts. 15 on a shelf, we could just keep track, right? This is just skip counting in table form. One shelf gets you 15 t-shirts. Two shelves get you another 15, that's 30. Three shelves get you another 15, 45. Four shelves get you another 15, 60. Five shelves get you where you need to go. You just need five shelves. Only 46% of our students were able to get this. Even if they were able to identify the operation, they probably got a little bit stuck with 75 divided by 15. You can also just do repeated subtraction, right? Division could be repeated subtraction. Just keep subtracting 15 until you get down to 0, right? That's your 30 minus 15, and so on and so forth, right? You get down to 15. You have to subtract 15 one more time to get to 0. And you just count. How many times did you subtract 15? 5. So, how do we help our students with this? Well, we need to understand that this was difficult, right? Because it's a one-step problem, but it's beyond basic facts. So we learn up to 10 times 10. Some teachers still teach up to 12 times 12. That's fine. It's not the standard, but if you've been teaching for a while, that's what third graders used to have to be able to learn up to. Either way, 15 is beyond that. And 27% of our students chose the answer found by adding A. So let's look at if you just 75 plus 15, right? You just add, you're going to get A. So when we have 27% of our students choose that, and only 46 got the correct answer, that means that was a huge distractor. And when you just take all the numbers and add, that means you really don't know what's going on. So step one is we need to create our own representation to visualize the problem. Visualizing the problem with a representation, whether that be a strip diagram, whether that just be pictures with shelves, like you could just draw shelves, right? And just count how many 15s it takes to get up there. That is what's going to help students identify the correct operation. And then we need to provide them strategies to find quotients beyond basic facts. I modeled two. So we did some repeated addition, some skip counting up. You could do repeated subtraction. There are ways to get to these larger quotients beyond basic facts, because once it's been tested once, there's a good chance we might see something like that again. So the next one is 3.5e. So we've got 48% mastery here, and we are representing real-world relationships using number pairs. Only 48% of our students got this correct, and we've got 6 burritos for every pound of meat, right? So let's just create our own little table here. That's probably the best way to do that. So burritos and meat. So 6 burritos with 1 meat, right? So let's just double that, right? So let's just do 12 burritos for 2 pounds of meat. Before we go on, let's see if anything even matches this. First off, A doesn't make any sense. It's not 7 burritos for 1 pound of meat, it's 6 burritos. So let's get rid of that. Okay, I've got 6 burritos for 1 pound of meat. I've got 12 burritos for 2 pounds of meat. So before I evaluate the next 2 rows, because you know it's a big jump, those two work. Look what we did here. We switched. We switched 6 pounds of meat for 1 burrito. Do you realize how large that burrito would be? That's a family size burrito. That's a share burrito. 6 pounds of meat for 1 burrito. They switched the labels, and then that's just not going to work. So, but that's something that students might get tripped up on if they're not reading the labels of each column correctly. And then look, I've got 6 burritos for 1 pound of meat. That works, but now I've got 12 for 7. So they just did a plus 6 here and a plus 6 here. But it's supposed to be, if we're using a multiplicative relationship, 2 pounds of meat. So honestly, look, B is the only one that works. Because what we're doing is we're taking our number of on the left, number of burritos, we're dividing it by 6, and we're getting our pounds of meat number on the right. So 48% of our students got this correct. And so they had to interpret this rate, but it was in an atypical order because the independent variable, pounds, right, of meat, that's listed second. So honestly, if we go back and look at this, this even took me a little while to understand because this is, right, the independent variable, which is not something that they learn yet, but something they will start dealing with. It's actually listed in reverse order. So that might have thrown students off because there was something a little bit off about that problem. And then 24% of the students chose D, which is that one distractor because the first row worked, but they just added 6. They weren't necessarily going to that second row. But when you had 24% of your students choose D and only 48% students choose the correct answer, that's a huge distractor. So, how can we help our students? Well, they can use words to describe the multiplicative relationship, right? So instead of always trying to find a rule, we can use words to divide by 6, or is 6 times as much, depending on which way you're reading it. Have them solve for the answers and then substitute into the representation. So kind of like what we did right here before I even started, I just extended the problem itself, created my own table, and then I matched it up. And then they need to create, if they create input-output tables, that's when you're going to get the real-world opportunities for them to order these relationships between columns, not within the columns. Because that's what tripped up the problem right here, is they knew it was 6, and so they just saw, oh yeah, I'm just adding 6, adding 6. But if they're creating their own input-output tables, what out of order, right? So you don't have to put the x value, the independent variable on the left. They could do it in either in either situation, right? That will help them understand that the relationship exists between the columns, right? The divide by 6 or the multiply by 6, depending on which way you're going, not up and down, not within each row. So when they're creating their own input-output tables rather than simply finding them or answering them or filling in blanks, that's what helps them understand which way the relationship goes. So next, we are looking at 3.7b. This is reporting category 3, only 49% overall mastery. And so we are determining the perimeter of a polygon when given a missing side length, or you have a, different polygon other than a rectangle. And obviously, take a look at our items there. 71% was able to get 6 correct, which is very simple, right? We just need to add all the way around, find 36. This is 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 24. So really, it's everything except for T. So we're looking for P, Q, R, and S. That's our answer right there. A. This seems like such a simpler problem, but only 27%. And guys, 27% out of multiple choice, that means we're just guessing. We really don't know what's going on here. Draw a rectangle. The perimeter is 40 inches, which means, and they know that perimeter means add up all the sides because they were able to do that one correctly. So we understand what perimeter means. We're adding up all the sides. A width, doesn't matter which one is the width. Let me call this one 5. So what is the length? I need this. Well, if we have a picture, if we know that this is 5, then we know that this is 5. And if we know that the top is a question mark, we know that the bottom is a question mark. So we don't need algebra to do this. We can use basic reasoning, even though this does set up to be an algebra problem. I'm adding up all the sides. 5 plus 5 plus question mark plus question mark equals 40. Well, what's 5 and 5? 5 and 5 is 10. 10 plus question mark equals 40. So what's the plus question mark plus question mark? Well, 10 plus what makes 40? So these two equal 30, but I don't want to choose 30 because there's two different sides that make up 30. If I put in 30 right here, my perimeter is much larger than 40. We need to check our work. I've got two different question marks that split 30 evenly. So that means I need to take 15. And let's check our work. 5 and 15 is 20. 5 and 15 is 20. 20 and 20 is 40. We need to set this up, get a visual, create an equation, and realize that the 30 needs to be split in half into our correct answer of A, 15, which only 27% of our students was able to answer correctly. So we've seen this, guys. We've seen this multiple times before STAAR redesign, after redesign. Students in third grade can just basically guarantee they're going to see a problem like this. This is even a problem that we should see on the fourth grade STAAR as well. You have a rectangle, one side given, no visual. This is not something that we should be surprised to see. More students chose D on that answer, 37%. So look, they chose this, which is just take my two numbers and subtract, then the actual correct answer. 37% chose D, which means they didn't really know what to do. So always draw a picture and label it. So even if you can just get the beginning of this picture with 5 and question mark, if you can just get your basic 5 and question mark, you've started. You're on the path. Because then students can start to visualize that they just need tons of opportunities, right? They're going to eventually use this in fourth grade. They're going to use this particular formula, P equals 2L plus 2W. You can do that if you want to. You can use P equals length plus width, or you can do what I did and just say, look, perimeter's adding up around all four sides. Let's just add some of the missing side lengths. Now, the difficult part here is this step, to where if they did 10 plus question mark equals 40. They might need some time thinking through that, maybe modeling that with some, some hands-on manipulatives, right? They don't need to know yet that what they're going to do in algebra is they're going to subtract 10 from both sides to keep a balanced equation, right? And they don't need to get to 2x equals 30. They don't need that yet. They're not ready for that visual. But what they can do is they can reason. They can say, look, 10 is how far away from 40. They made it nice, you know, nice round numbers for us. And then we have to split that 30 in half. They can do that. So 3.3H, 57% got this. So a little bit better. One problem. We're comparing two fractions, but we're reasoning about their sizes and justifying the conclusion using, a lot of times it's going to end up being words. And so here we've got inline choice, we've got Serena, we've got Ricky. So Serena's got 5, 6. So what I want to do here is I want to see if I can draw for you two different rectangles to visually represent what we're doing. Try my hardest to make the rectangles the same size. So I'm going to make 6. So what I do is I write create thirds, and then cut each third in half. For the eighths, I create a half, each half in half, and then cut each of those fourths in half. And let's see if we can get just a little bit of shading here. So I'm going to just do some shading. Here's my 5/6, and here's my 5/8. Hopefully we can see here that Serena is greater, right? We can see here visually that 5/6 is going to be greater than 5/8 because we've got, it extends a little bit farther. They both have the whole top row, but then there's a little bit more, but we don't even need the visual. We know this because they have the same numerator. So in third grade, they're just reasoning based on the numerator or the denominator. If they both have 5 pieces, then Serena drinks. So Serena's the 5/6. So we need to be able to say, here are our answer choices. More of a milkshake than Ricky because why? Because sixths are, here's the thing. Did you notice that the sixths are larger? This was the correct answer down here. 2-point problem. Sixths are larger than eighths. They need to know that each of these sixths are going to be larger than eighths. So 5 pieces of the larger six is going to be greater than 5 pieces of the smaller eighths. And how do we know that six are larger than eighths? Because they're both out of the same hole. And if I cut something into 6 pieces, those pieces are necessarily going to be larger than cutting that same hole into 8 pieces. Because imagine if I cut it into 100 pieces, cut into 1,000 pieces. You realize how tiny those pieces are going to be? The more pieces I cut that hole into, the smaller each piece is going to be. And that's what we need our students to think through. So we had 46% of our students get full credit, 21% get partial credit or 1 point. So we take half of that, that rounds up to 11. And so our 46 and our 11 is what gets us our 57%. Correct. We don't know which one they got correct and which one they got incorrect for those that got 1 point because we don't get that information from TEA. So how do we work through this? Well, it was difficult because we had to compare fractions with unlike denominators and like numerators with no visual. So if they can draw a visual, that can help. But did you notice that my visual was very meticulous in how I drew the sixths and the eighths, and I made sure that each rectangle was the same size? It is a good scaffold for students that can have good drawing abilities, but if they're going to draw them of different sizes, then the visual will make it harder. Because honestly, either way, you need to make the comparison with words and a rationale rather than simply with symbols. So there's no greater than or less than necessarily needed. We need the words and the symbols. So we need to give them opportunities to explain how, and this is the hard piece, this is the big piece of learning in third grade. The number of pieces affects the size of each piece. They need to know that the more pieces there are in a whole, the smaller each piece is going to be. And it's that inverted thinking that can sometimes be difficult for students to grab. They think the larger the number on the bottom, the larger each piece is going to be. But the larger the number on the bottom, the smaller each piece is going to be. That's hard for students. So we need to give them lots of practice with that. And then this is a great opportunity for writing practice. The answers need to be in words anyways. Have them write an SCR, write a short constructed response explaining this, just 1 or 2 sentences, how they know. Who's bigger? and how they know, right? So just take this whole part and delete it and just give the stem to students. And they have to write 2 sentences. Who's got the bigger milkshake and how do you know? And there you go. There's your SCR practice. So we got 3.3F. We are representing equivalent fractions with denominators of 2, 3, 4, and 6. This is a multi-select item. And so we've got 33% with full credit, 50% with partial credit. So half of us can only get one correct. And there's one obvious one here, right? So if we're looking at the number of pieces, right, I've got 3 pieces, so these are thirds, 0 third. Each tick mark is going to be my portion. So I can guarantee you that a good chunk of the partial credit people, they got the 1/3. So we are able to get this. The question is, what's the other one? Well, what kind of strategies have we taught our students to take these and generate equivalent fractions using a model? Well, one way to do that is to take each chunk, cut it in half, and take a look. I'm going to draw a line, a blue line over the tick marks now. And now look what I've got, right? So this is my 0, but how many pieces do I got? 1, 2, 3, 4, 5. I've got 6 pieces now. So this is 0/6, 1/6, 2/6, 3/6. We notice that's halfway, so 3/6 is equal to 1/2. 4/6, 5/6, and 6/6. All you have to do is draw it in half, cut each third in half, and realize, okay, 1/3 is the same as 2/6, so these are my 2 answers. But only 33% of our students were able to get that correct. There was no visual support there unless they wanted to draw, use the graphing feature, move the transparency up to all the way where it's transparent, and they can actually use the graphing feature to draw on the problem. They would need to be able to cut that number line into smaller pieces. This is a hard concept for students. You can talk about it all day long. What they need is practice, practice, practice with number lines. They need it with just regular pictorial models. They need concrete objects. They need a firm understanding that when I say that 1/2 is equal to 2/4, they need to be able to represent that and tell me why. What we're not doing at this point is we're not going into the algorithm of just multiplying top and bottom by the same number to get to a new one. This is the fast, efficient way that happens later, much later, after students have a firm understanding that 1/3 is the same as 2/6 if I cut each third in half. I need them to understand this with visuals first before they get into this. This comes later. We'll get into this in 4th grade. So let's please not do this in 3rd grade. They need to be able to have lots of opportunities to where they're taking just a circle. Let's take our circle. Let's cut it into thirds. Okay, so how do we make an equivalent fraction? Well, one way is to take each of these lines and extend it, right? And now let's assume that these are equal parts. I try to draw them as quick as equal as I could, but now I've got 6. I didn't change the amount that was shaded if I originally had 1/3 right here. All I did was change the number of pieces that there were by cutting each piece in half. If they can do that, they can start to understand equivalent fractions. And then finally, we've got 3.2D, and we are looking at comparing and ordering numbers, and we have a mystery number here, okay? So the number is between these two numbers. So I'm going to just draw a number line here, right? So 89,000, right? So I'm going to just draw a number line. All right, so I'm going to include 89,000, and I'm going to include, let's do this. I'm going to include this right up here, 91,000. So I just want some big round numbers. The number is greater than 89,236. So let's say I'm going to say 89,236 has to be between that and then my 91. Let's put that on this one, 91,103. So first, I just need to find something that's between those two. We'll get into this last one in just a moment. So look at this, 88,598. Well, 88 is going to come down here, which means 88 is not going to work. 91,057. Okay, so 91,057. It's going to go right here. So we're good. the 91,000 works, and because the 057, 57 is less than the 103. So that's a possibility without looking at that last item. 89, 099. Okay, that's going to work. Well, it's not going to work because look, the 099 is less than the 236. Look, it comes right here, and that's below, so that's not going to work. And then I've got my 89, 572. That's going to come smack in the middle. So really, I have two options. So it's going to be this: a digit as a 7 greater than 7 in the thousands place. What's in my thousands place? It's going to be my 1 and my 9. My 9 is greater, so my answer here is going to be D. So we had to answer these clues, but the best way to do that probably would be to build some type of number line. And you had to compare numbers and you had to use the value of a digit. So they really mixed and matched this one. So have them draw a number line like I did. Place these numbers in space. So they need practice with open number lines, creating open number lines, and being able to reason about numbers in space. And a lot of times this particular standard is asked for with just you got four numbers in a table and you need to put them in order and tell me which one is third. So that's one thing they need to do. But if they don't have practice with these mystery number problems, there might be some students that have the capability of doing this. They're just not used to the format and they struggle. So those are our top items that we missed for reporting category in the different readiness standards in all the different reporting categories of the third grade 2024 Math STAAR.